Hey, sir.
Okay, hopefully everybody got okay, good. Let's see. Am I being heard?
Yes, sir.
Yes, sir.
Okay, cool. Always got to make sure on that part. And let me see what else I need. Oh, I need to open up I need to open up my chat window. Okay. And, oh, okay. So my search isn't working anymore. Oh, that's lovely. Thank you, Windows, for screwing up my computer. I do that enough on my own. I'm just finishing setting things up on my end. Forgot to set this thing up. And no, that's not what was supposed to happen. I just wanted to move it over to here. There we go. I gotta find the PowerPoint again. Okay, where'd we leave off? I know that was a week ago. Had we finished, had we done phase shift? Don't forget to sign into the chat. All right. Let me see. Where did we leave off? I'm gonna pull this slide up and see if it was here. All right. Next thing. Do this. Back up again. And come over here and do screen share. There it is. No, that's not what I wanted to do. That's what I wanted to do. And there we go. Yeah, I'm sorry. I'm getting things set up again. So. And pull up the chats. Okay, please be sure and sign into chat. Right now, I'm making sure I can see all the chats. Trying to move everything so I can see everything. Okay. All right, did we do the phase shift? And curve fitting, I'm not too concerned about. So did we do this?
I'd have to see some of the problems to remember because it's been a bit. So we missed our last class where we used you for homework, which helped.
Well, that's good.
Yes.
So the where y equals a times sine of omega x minus phi
I'm pretty sure we did some of this.
plus b. Yeah, we've done that. I remember doing it in the
Yeah,
class.
that looks familiar.
Yeah.
Okay. So, yeah. And well, let me do it this way. Yeah, we looked at doing the curve fitting as well, right? So this is what I was thinking we were getting close to. Or had we done this where we're talking about sine inverse of x, cosine inverse of x, tangent inverse of x, and as well as the other ones. Had we gotten into this yet? Because yeah.
No, we haven't.
But we had done the finding the sine function of best fit. That's where we're given this particular problem, and I think they only gave us one problem, or they gave us two. I don't know, but it's looking at the data that you have, and let me back up even more. Yeah, so this kind of deal here where you're trying to make it fit make the curve fit the graph. Right, that's what the thing is what we do with that. And I don't test you over this, but it's in the homeworks. And it's finding out, well, finding alpha, finding A, and finding what omega and phi are, and finding the B. So this would be the vertical stretch, and this would be the vertical shift. So we're shifting up 52 units, and we're stretching by multiplying by 22 units. we're changing x by subtracting 4. So we're shifting the graph to the right 4 units. And then we're doing a compression. We're increasing the frequency with omega. Okay. And then the steps to find those things. So I'm just clicking through these to get to chapter 7. Okay, 7.1, talking about inverse sine, cosine, and tangent functions. We're going to define what they are and then find their values. So we're going to look at them individually. So we're going to find out what the inverse sine is, and finding the value of a sine inverse, and then find out what cosine inverse is, or the inverse of cosine, and with tangent. And then we're going to use the properties of inverse functions to find exact values of certain composite functions, and then find the inverse of function of a trig function, and then solve equations involving sine and cosine. I mean, trig functions, inverse trig functions. So this is a sine function, and please notice what's in blue here. I don't know if it shows blue on your screen as well, but we're just looking at this portion of the graph from pi over 2, from negative pi over 2 to pi over 2. So we're only looking at a portion of the sine function. We're just looking at the sine function where it covers all of the range. So from negative pi over 2 to pi over 2, it covers all of the y values. Okay. So we're restricting our domain in this case, because the inverse is going, instead of going from x to y, we're going to go y to x. Y equals sine inverse x if and only if x equals a sine of y, where y is theta between negative pi over 2 and pi over 2, and x is an real number between -1 and 1, and both of those intervals are inclusive because it can equal the endpoints. And the graph in red down here is the sine, but in the blue it's the inverse. Notice that they're symmetric across the y equals x line. So this point and this point, you flip the x and the y, you get the other point. And that happens all the way down. And that happens all the way here. And where they intersect is when x and y are the same value. So in this case, at 0, the y value is 0 for both of them. Okay. So when we're doing this, we're actually looking to see. So they're saying inverse sine, and that's how we write it, inverse sine of -1 equals some theta. That means what sine of theta equals -1. So in the interval from negative pi over 2 to pi over 2, does sine equal -1? Okay. And so, because by definition, y equals the sine inverse of x, which means that sine of x equals that sine of y equals that x value, and y is the angle we're looking for. So, and so we typically call it theta. So what angle equals the sine of what angle is -1? Can anybody tell me? Well, what they do is they throw the chart up at you. The chart from, so, and I always go back to the unit circle, and they're talking from negative pi over 2 to pi over 2. So we can forget about this half of the unit circle. We're only talking about these angles here. Okay. And we're talking, if it's an angle in the first quadrant, we're talking the positive, and if it's an angle in the fourth quadrant, it's the negative. So this would be negative pi over 6, where this here is pi over 6. So which angle gives us -1 for sine? All right. Well, all you need to do is read the chart. Negative pi over 2, and you should know that by now. Which angles gives us these things? Okay. So the only angle in the interval whose sine is -1 is -1/2. Please notice that 3 pi over 2 also equals 1, but 3 pi over 2 is not in this interval. So that's why we're talking about the negative and not the not, because 3 pi over 2 would be going like this, but it has to be here. It has to be this direction. So it's the negative pi over 2. So the sine inverse of -1 is pi over 2, negative pi over 2, sorry. Because -1 happens here, and happens here, and happens down here, and happens further down, and happens this direction as well. But we're only looking at this interval here between these two x values, including those x values. So -1 only happens here in this interval. Okay. Now, to find the exact value of 3 pi over 2, well, so if we want to find the sine inverse or inverse sine of the square root of 3 over 2, we want to find that angle. So then we say that the sine of that angle, sine of the angle we don't know of yet, is the square root of 3 over 2. Well, sine is positive in this quadrant, in the first quadrant, and so we're looking for a positive angle up here. So we're looking at the y values of these angles. Okay. So this has gotten a little messy. So the angles we're looking at in here, you have this point here, which is the square root of 3 over 2, 1/2. And then this point here is the square root of 2 over the square over 2 and the square root of 2 over 2. And then this point here is 1/2 square root of 3 over 2. And then this point up here is 0, 1. So the sine is the y values of each one of these. And this angle here is 0, and it is, this point here is 1, 0. So there we have the sine values, which are just the y values here. So this one has, whatever the angle this is, gives us the square root of 3 over 2 for sine. Okay. Right. The angle is going to be between negative pi over 2 and positive pi over 2. Which angle in that range equals square root of 3 over 2. And so they set it up the same way they did before. And where is that phone? Ah, there it is. Shut up. I'd put it up high and I couldn't. Anyway.
I had a bunch of alarms earlier too. They were annoying me.
Those things happen. Okay. And so the only angle in that interval, this is pi over 3 or 60 degrees. This one is pi over 6 or 30 degrees. And this one is pi over 4 or 45 degrees. This is 0 radians. And this one is pi over 2 or 90 degrees. Now, most of the time we deal with radians. We either write it using pi or we use the word radians. If we have pi in the number, we don't use the word radians with it. It's understood to be radians. If we don't, like if we wrote down 2.3, we would use the word radians with it if we're talking about radians. Helps if I spell it right. So in this interval, we only have one angle that gives us square root of 3/2 for sine. And so that's our solution. So that's how we do these. So here they're asking for the approximate value. Now, in the calculator, let me see, I got this one here. In the the TI-83 calculator. I don't know, can you see that? Okay. Let me see. We have sine, cosine, and tangent. And right above it, it has sine inverse, cosine inverse, and tangent inverse. So you would use the second and then the sine key to get sine inverse. And so that's how you would do this. You would enter this in as sine inverse 1 divided by 3 for 1/3. Don't forget to close the parentheses and then you hit enter. Same thing for the 1/4. You type in sine inverse and then you type in the 1/4 and then you hit enter. Okay. All right, so first thing to do is to make sure that the calculator is in radians. So you'll get radians back. And so the angle measure that gives me it gives me 1/3. So I'm looking at the sine of what angle gives me 1/3. Well, that angle in this case would be 0.34 radians. Or RAD. You'd abbreviate it to rad. All right. Typing it in the way I said here was what they did. So the sine inverse of negative, oh, it was -1. I missed the negative sign. -1/4 gives you an angle measure of a negative 0.25 because they're rounding to the second decimal place. All right. Okay. Now, cosine inverse. The cosine part is in red, right? The cosine graph goes like that. And their sense of one period, the period here, what they're looking at is from 0 to pi. So the angle measure from 0 to pi covers all the y values from -1 up to -1 up to 1. Right? Because the cosine inverse acts on the -1 to 1 to give us these angle measures from 0 to pi. And where they intersect is when the x and y are the same number. Okay. So finding the exact value here, okay, again, I always, well, let me not run away. We're gonna go ahead and use this page. So cosine inverse of 1/2, but cosine is measured from 0 to pi. -1, 0 is that point. So this is pi over here. And so we're looking at the positive angles from 0 to pi. With sine, where we're looking at the negative and the positive angles from negative pi over 2 to pi over 2. But now we're going all the way over to here, but we're starting here. It's half a period for cosine, but for inverse, we're just looking from 0 to pi because that covers all the y values, -1 to 1 in the cosine. So asking for cosine, what angle gives us that? Or what's the angle that is given by that is saying the cosine of what angle equals 1/2. Well, now cosine is the x values. So now I go through and I look at the x values, which x value is 1/2. Well, that's when it's pi over 3. So the cosine of pi over 3 equals 1/2. So the cosine inverse of 1/2 equals pi thirds. And again, they wrote a chart from 0 to pi, all the designated angles that we use. And these are the x values for those angles, the y for the points on those angles. And so this is the cosine of each of those angles, and we're looking for 1/2, and 1/3 gives us 1/2. So 1/2 gives us 1/3 pi. All right, the only angle in the interval 0 to pi whose cosine is 1/2 is pi thirds. All right, 5 pi over 3, which is over here. No, that's not right. That's over here. Yeah, 1/4. Yeah, 4 pi over 3 is over here. But 5 pi over 3 is over here. But we're only looking at angles between 0 and pi. We're not looking at these down here. Now the cosine, that equals a negative square root of 3 over 2. Well, in the first quadrant, cosine is positive. In the second quadrant, cosine is negative. So what angle in the second quadrant has a cosine of negative square root of 3/2? In other words, which point here on the unit circle has an x value of a negative square root of 3/2? Well, this point down here, we'll start with this one up here. This one is a negative 1/2 square root of 3/2. See, it's going to follow the same pattern as these points over here. It's just going to be the reverse, and the sign will be negative. I mean, the x value will be negative. So this one is going to be square root of 2/2, square root of 2/2, but the first square root of 2/2 is going to be negative, and the second one is going to be positive. And this is the square root of 3/2, 1/2. So this one over here is going to be square root of 3/2, 1/2. But the square root of 3/2 is going to be square root of 3/2 is going to be negative, and the 1/2 is going to be positive. So we're just looking at the cosine values. And so, and this is what is this? 2 pi over 3, and this is 3 pi over 4, and this is 5 pi over 6. And so that's all we're doing. We're looking at what angles in that range in that domain from 0 to pi that has a cosine of a negative square root of 3/2. And that angle happens to be 5/6, right? Which is the 5/6 here. And they have that nifty little graphic that showed it as well. Okay. So the only angle in that interval is 5 pi over 6. So the cosine inverse of negative square root of 3/2 is 5 pi over 6. Inverse tangent. All right, inverse tangent. The range is the same range as on sine, but the domain is all real numbers. It's not limited to be between -1 and +1. So find the exact value. So I'm going to look at that interval from negative pi over 2 to pi over 2, but it's an open interval now because they did not include the equal sign. Because for tangent at pi over 2, the tangent doesn't exist. And same thing with negative pi over 2. Tangent does not exist because in those two cases, you're dividing by 0 because tangent is y over x. So they're asking for tangent inverse of 1. In other words, the tangent of what angle equals 1. Since tangent is y over x, then that's telling me that y and x have to be the same. So what angle between pi over 2 and pi is x and y the same value with the same sign? Well, that's up here because negative square root of 2 over 2 and square root of 2 over 2 and square root of 2 over 2, when you divide them, you get 1 because you have the same number over itself. So tangent of pi over 4, tangent of 1/4 pi equals 1. So that means that tangent inverse of 1 equals pi over 4 radians, or 45 degrees. So next one we do the same way. We're looking at the tangent of what angle gives us the square root of 3 over 3. So, but negative, right? Tangent is positive in the first quadrant and the fourth quadrant, because those are the two quadrants we're looking at. But in the fourth quadrant, tangent is positive in the fourth quadrant, but we're dealing first quadrant, but we're dealing with the fourth quadrant, and tangent is negative down here. So we're dealing with an angle that's going to be a negative angle. Okay. And down here, the sine is negative, but the cosine is positive. So this is going to be the square root of 3 over 2 comma negative 1/2. This one is going to be the negative, not negative. It's going to be the square root of 2 divided by the square root by 2, and square root of 2 divided by 2. Those two are the same. And oh, that's negative square root of 2 is the y value. And then this one here is going to be a positive 1/2 and a negative square root of 3 over 2. So my only two choices are this angle up, oh, that's negative down here, is a negative, oh no, it's not negative, because we were talking positive. All right, negative pi over 6, negative pi over 4, and a negative 1/3 pi over 3. So the only, and since tangent is y over x, then I have two choices. It's either this one up here or this one down here. It's either negative pi over 6 or negative pi over 3. So I look to see which one of those, the ordered pairs, gives me square root of 3 over 3. So it depends upon which one the fraction works. I'm going to choose this one here because that's what I'm looking at. And so the y value is the square root of 3 over 2, and the x value is 1/2, and this is going to be negative because we have that negative there. Well, the 1/2 and the 1/2 go to 1, so this is just the negative square root of 3, which is not a negative square root of 3 over 3. So it's going to be the other one, which I'm going to do it over here. You have 1/2 being divided by a negative square root of 3 over 2. So these go to 1. And so this is just a negative 1 square root of 3. Multiplying numerator and denominator by the square root of 3, you get square root of 3 over 3. And so that angle is a negative pi over 6. So the tangent of negative pi over 6 equals the negative square root of 3 over 3. So the tangent inverse of a negative square root of 3 over 3 equals a negative pi over 6 or 7 pi over 7. But we're dealing with the first with only these two quadrants. Well, the values from negative pi over 2 to positive pi over 2. And so here they're doing the first one. And then they didn't say what the angle is. They didn't give us the answer here. For number 1, they don't say what the answer is, but the answer is pi over 4. Right? That was the first one. Did I erase it already? No, there it is right here. That was this one. And so, well, here they create the table. And so in that, from negative pi over 2 to pi over 2, there's only one theta that will give us a negative square root of 3 over 3, and that's a negative pi over 6. Okay, properties of inverse functions. When you compose the two functions, that means you put one function inside the other one. You get the argument back. So sine inverse of sine gives you x, and sine of sine inverse gives you x. So it undoes what was being done, provided that the number is the number you're using for x is within that domain. So like on equation 4b, I wouldn't be able to use a number that is larger than 1. I can't put 2 in here and expect to get an answer because 2 is not in the domain of sine inverse. Okay. So inverse functions undo each other. This is just quite literally the definition of inverse functions, or part of the definition, I should say, is that when you compose the two functions, either way, you'll get the argument back. So if I put 0.5 in for x here, then I'll get 0.5 back out again. If I put a negative pi over 4 here, I'll get negative pi over 4 back again. No, I said that wrong. This one is with the negative pi over 4, and this one is with the 0.5 and 0.5. Okay. So sine and cosine, sine and sine inverse just undo each other. You get the argument back. So here I'm doing sine inverse on sine. Well, sine of pi over 8 gives us some number that when I do the inverse on it, I'll get pi over 8 back. All right, we'll look at the second one in a second. All right, the composite function follows the form of property A because pi over 8 is in the domain. Then you can use property A to say that it just takes you back to pi over 8. Now, letter B also follows the form of property A, but 5 pi over 8 is not in that interval. 5 pi over 8 is larger than pi over 2. So it does not equal pi over 8. But we want to look in that interval. We're going to look at the interval between negative pi over 2 and pi over 2, for which the sine of that angle is the same as the sine for 5 pi over 8. And here's a nice picture. So this is where we start talking about reference angles and quadrants. So what we have here is this is 3 pi over 8, and this is pi over 8, but the angle on this side, it's supplementary, no. Yeah, its supplementary angle is 5 pi over 8. I mean 3 pi over 8. So we use 3 pi over 8 to determine the A and the B. So because the B value is the same on those two angles, that's the Y value. That's the sine value, sorry. Yeah, the Y value, which is the sine value of this angle. So the sine of 3 pi over 8 is exactly the same as the sine of 5 pi over 8. So the inverse, so the reference angle for that is 3 pi over 8. And since 3 pi over 8 is in the interval, we can use the formula for A, where it's going to give, so these two things in here are equal. So it gives us 3 pi over 8. Because the sine inverse undoes the sine. Now this is the same thing. Only we're doing the sine on the sine inverse, not the sine inverse on the sine. Well, for sine, the x has to be in between -1 and +1 inclusively. Well, if it is, then the sine of the sine inverse of that number is that number. So letter A just equals 0.5, a half. Well, looking at letter B, -2.5 is not in that interval. So we can't, so it has no answer. It's undefined. Or there's no solution. Because negative 0.25, we cannot use in sine inverse. There's just no way. With sine, we can find reference angles that we can use that give us the same sign. So we can use that. But with sine inverse, it's kind of, well, you're flat out of luck. Because there's no angle. There is no angle for sine that will give you a negative 2.5. This angle does not exist. So, yeah. So we're flat out of luck there. Now we're talking about cosine now. Cosine is the same kind of deal, but now our domain has changed for the cosine. Well, it's instead of going from negative pi over 2 to pi over 2, now we're going from 0 to pi. And so we're end up doing the same thing. But in 5a, be aware that theta, that the angle has to be between 0 and pi inclusively. And with cosine inverse, just like with sine inverse, our values here are restricted from -1 to 1, and that can't change. Well, with here, we can do a reference angle to get us there. So 15 over pi, pi over 15, so the question is pi over 15 in this spread between 0 and pi? Well, yeah, it's a positive fraction less than pi, because 15 is larger than pi, which is 3.14. So, yeah, it works. So this is just pi over 15. So letter A, we get pi over 15. And letter B, looking at letter B, now we're having the cosine of a number, a cosine inverse of a number. Well, that number has to be between -1 and +1. Well, yeah, negative 0.04 is between -1 and +1, so we can use it. We can find a solution here, and it is negative 0.4, because cosine undoes its inverse, and the inverse undoes cosine. So same thing's happening on letter C that happened in letter A, except now negative square root of 3 over 4 is not in this portion of the unit circle. It's down here. But what angle gives us the same cosine of negative pi over 4, but it's in this, it's in here? Well, actually, it's going to be up here. Okay, so 3 pi over 4, negative 3 pi over 4 is down here. So if and cosine has the same sign here and here, And they're going to have the exact same cosine. So instead of going negative 3 pi over 4, what if I went 3 pi over 4? That's going to get me in this quadrant over here, and it will have the same cosine as this angle down here. So the cosine of negative 3 pi over 4 equals the cosine of 3 pi over 4. So I use that instead of the negative 3 pi over 4. And so the inverse cosine of the cosine of negative 3 pi over 4 is the same as the inverse cosine of the cosine of 3 pi over 4, which just equals 3 pi over 4. So letter C is 3 pi over 4. And letter D, well, pi, they put pi here. This is a trick question. This is trying to trick you into thinking that, well, this is appropriate to use here for inverse cosine because it's pi and we're dealing with pi and it's in the interval 0 to pi, but we're dealing with cosine. Cosine has to be a number between -1 and +1. Pi is approximately 3.14, which is greater than 1. So I can't use it. So on letter D, we get no solution, or undefined, or not defined. Textbook is fond of using the phrase not defined in these cases. So letter A, they got the same thing as I did. And it's just straight from the property 5A. Letter B is the property 5B. And so it's just the argument. And 3/4 is not in the interval, but -3/4, but 3/4 is, and it has the same cosine as negative pi over 4. So the cosine inverse of cosine of negative pi over 4 is the same as the inverse cosine of 3 pi over 4, which is 3 pi over 4, because we're undoing the cosine. We're undoing the function. We're getting the argument back. And pi is not in that interval, so cosine inverse pi is not defined. Okay, it's undefined, or does not exist, or gives us no solution. So that composite function is not defined. We don't get an answer. Okay. Now with tangent, please notice the domain for inverse tangent oh, wait a second. The domain of inverse tangent is all real numbers, and tangent, the angles have to be between pi over 2 and pi. Because if you remember the graph of tangent, kind of looks like this, where we have the asymptotes over here at negative pi over 2 and pi over 2. So the graph itself approaches these vertical asymptotes but never reach them on either side. Okay. And so that's the kind of deal we're looking at. And then we're just dealing from here to here. And so when we rotate this thing, so we're talking about trying to remember how it goes. Oh, it's going to be flipped along this line. So yeah, so it comes like this now. Actually, they intersect at the point 0, 0. So my graph there is a little wonky. Okay. Where the domain is all real numbers and the range is between negative pi over 2 and pi over 2. So negative pi over 2 down here and positive pi over 2 up here, we have now we have horizontal asymptotes instead of vertical asymptotes. Okay. So find the inverse. So y equals 2 sine x minus 1. Well, to find the inverse, you switch the y and the x. So this is going to be x equals 2 sine y minus 1. Yeah. So then we just interchange, we interchange the x and the y. And now we want to solve for sine y first. Okay, so that means we're going to add 1 to both sides. And then divide by 2. Okay, they like to, so they went ahead and switched the sides while they did this. So they would have wound up with x plus 1 over 2 equals the sine of y, and they just switched sides of the equal sign. That's called the symmetric property of equality. A equals B means B equals A. Yeah, A equals B if and only if B equals A. That's the symmetric property of equality. Like 3 plus 5 equals 8, and 8 equals 3 plus 5. You're just switching the sides of the equal sign. Okay, enough of that. And so then you just do sine inverse. And there you have it. The inverse of y equals 2 sine x minus 1 is y equals sine inverse of x plus 1 divided by 2. And so that's the inverse function of f. Okay. To find the range, we use the fact that the domain of f inverse equals the range of f. Well, the range of f is between -1 and 1. So that means the domain is between -1 and 1. So x plus 1 divided by 2 has to be between -1 and 1 for us to be able to use it. The argument has to be in between those two values. Now we just, this is a triangular inequality. That means you have three values involved in a inequality, where you have a middle value and then you have a low value and a high value. Now, you just solve this the way you would solve an equation. I multiply everything by 2 because that's what's in the denominator here. So 2 times -1 is a -2, less than, I'm not multiplying by a negative number, so I'm not going to worry about my inequalities. And this becomes x plus 1, which is why we want to multiply by 2 to get rid of the fraction. And this is going to be less than or equal to 2, because 2 times 1. And now we're going to add 1 everywhere. Plus 1, no, we're going to subtract 1, I'm sorry. So -1 down here, -1 in here, and -1 over here. So it all remains equal or unequal in the same ratio. And so here we have a -3 less than or equal to x less than or equal to 1. So our domain is between -3 and 1, including -3 and 1. Yeah, they went ahead and did the same thing and then multiplied by the 2 and then subtracted the 1. And so the domain of F inverse is -3 less than or equal to x less than or equal to 1, or the interval -3 to 1 inclusive. And the range of the original function is between -3 and +1. Because the range of 1, excuse me, the range of 1 is the domain of the other. The range equals the domain of F. So the domain of F is between -π/2 and π/2. So the range of F is between -π/2 and π/2. Now, here, this is a typo. It should have been parentheses, because we can't take the tangent of π/2 or -π/2 or any multiple of π/2, odd multiple of π/2. Okay. Next thing. Now we want to find out what x is. So we have 12 times the sine inverse of x equals 3 pi. Well, sine inverse equals an angle, and this is going to be in radians. Okay. So to work backwards to get to sine, because we want to know, just want sine, because then we can take the sine of both sides and say that x equals sine of something. Okay, so to do that, we're going to divide by 12 here and divide by 12 on the other side of the equal sign. So now these go to 1, so we're left with the sine inverse or the inverse sine of x equals pi fourths. Reduce the fraction. You always have to reduce the fraction. And now I'm going to do sine on both sides. So x equals the sine of pi over 4. Right? Because if I take the sine of the sine inverse, that just gives me the argument of this of the inverse. And what's sine of pi over 4? Square root of 2 over 2. This is one of those numbers you need to have in your head. So x is the square root of 2 over 2. Boom, I solved it. So involving the single inverse, isolate the inverse trig function first. And so that's what we did. All right. And then you take the inverse function of both. Oh, then they simplified. And then you take this right here. Y equals sine inverse if and only if x equals a sine. And that's what they did. And so now we just need to deal with what's x? Square root of 2 over 2. So that's our solution set, square root of 2 over 2. Okay. Now comes a really fun part. Continuing with inverse trig functions, and that's dealing with the secant, cosecant, and the cotangent functions. And then finding the values of those and finding the exact value of a composite function of those. And then write trigonometric. I'm having a hard time talking right now. Expression as an algebraic expression.
Trigonometric sounds right.
Yeah. The trig functions. Okay. I'm so used to saying trig instead of trigonometry. Okay. So here's the definition of inverse secant, inverse cosecant, and inverse cotangent. All right, they follow the exact same pattern as sine, cosine, and tangent. You just have to be careful of the domain, that what angles you can get. All right, here with secant, it's from 0. The angles are from 0 to pi, just like with cosine. With cosecant, and well, with secant and cosecant, the x value has to be outside of 1 and -1. So for secant and cosecant, the values we're dealing with are any real number except for the numbers in the interval 1 to 1 exclusive. So it's an open interval where this is an open interval in here that x cannot be for secant and cosecant. And with cotangent, we're dealing with angle values between 0 and pi. Remember, cosecant is shifted a little bit off of pi, off of cosine, as far as what angles exist. For cosecant, for cotangent, it does not exist at 0, and it does not exist at pi. So we can't have those angles. It won't equal those angles, and those angles we can't use in the cotangent. The 0 and the pi. So secant equals 1 over sine. Right. So secant inverse or inverse secant of 1 is asking the question, what angle does secant equal 1? So secant of what angle equals 1? Well, sine 1 over sine equals 1. And so I multiply both sides here. So now I'm just looking at this formula here. So that means 1 equals the sine theta. Well, what angle of theta does sine make 1? Well, that's at pi over 2. So theta in this case is pi over 2. Right? If you remember correctly, secant goes like that and like this and like this, where this is positive 1 and this is negative 1. And I don't remember, oh, this is pi over 2. And 3 pi over 2 and 5 pi over 2 and then 7 pi over 2. That's where it's going to be 1 or negative 1. 1 negative 1 1 negative. That's local minimums and local maximums for cosecant. And secant has the same thing, it's just been time shifted. It has a phase shift there. Right. Letter B, we have cosecant, and so we're asking that what the cosine, not cosine, cosecant. Oh, I was wrong here. Secant is not sine. Secant is cosine. So secant theta equals 1 over cosine theta, and this equals 1. So the cosine of theta that equals 1, well, that's 0. That's 0. Okay. Now when we're dealing with cosecant theta, That one is 1 over sine theta. And this needs to equal 2, because that's what they're talking about here. All right. The angle cosecant inverse equal to 2 is the same as saying the cosecant inverse of 2 equals what is the same thing as saying the cosecant of theta equals 2. But cosecant is 1 over sine. So looking at this, multiplying both sides by sine, we get 1 equals 2 sine theta. And then dividing by 2, we get 1/2 equals sine theta. Well, what angle gives us the sine of 1/2? That's pi over 6. So theta in this case is pi over 6. Where up here, cosine, the cosine that equals 1 is the angle 0. And cotangent, okay. Cotangent inverse of negative square root of 3 is asking the cotangent of theta that equals the negative square root of 3. Or y. So that's going to be cotangent is, oh, hang on a second. My fuzzy brain. Cotangent, we're dealing with angles from 0 to pi. So cotangent, that angle has to be between 0 exclusive and pi. Well, that's going to be the second quadrant. And so that's going to be 5 pi over 6.
Sir, I have a question.
Yeah.
Where can I see the grade I got for the exam we took like 2, maybe 3 weeks ago?
I haven't finished them yet.
Okay, that's fine.
Okay.
All right, thank you.
Okay. So here they're going to go through it. All right. Notice that they say that theta can't be pi over 2 because cosine at pi over 2 is 0 and 1 over 0 is undefined. And so secant is 1 when theta is 0. So the secant inverse of 1 is 0. And yeah, so here I said this cosecant equals 2 or equivalent, sine equals 2. So what angle gives us a sine of 2? I mean sine of 1/2. That is the angle pi over 6. And then the cotangent the only angle from 0 to pi whose cotangent is negative pi over 3 is 5 pi over 6. So there we have that. And then these, again, you just punch into the calculator. Since you do not, well, let me see how they explain it. I know there must be a calculator out there somewhere that has the secant, cosecant, and cotangent, but I don't know what they are. So okay. So then we have the secant of theta equals 8, or the cosine of theta equals 1 over 8. So we do the cosine inverse of 1 over 8. And there we have it. Punch it into the calculator. Second cosine, 1 divided by 8, close parentheses, enter. Okay. And letter B, so that's cosecant theta equals a negative 1, or the sine of theta equals 1/2, a negative 1/2. And so we're going to take the sine inverse of a negative 1/2. So the cosecant inverse of negative 2 is the sine inverse of negative 1/2, the reciprocal of 2. And yeah, and you get negative 0.52 radians. They should have said radians there. So here we're going to deal with tangent, because the tangent of theta is going to equal 5. Oh, I see what they did. Okay, what they did here was the cotangent is 1 over 5. So that's x over y. So we have a right triangle. X is 1, y is 5, and the length of this side, whoa, is my Zoom is really messing up. Everybody's gone. Can y'all still hear me?
Yes, sir.
Yes,
Okay.
sir, I can hear you.
And I assume y'all can still see. All right. This is weird. Zoom has really been, I thought it was just with the computers at school, but evidently it's not. It's just following me around. Okay. So they use the Pythagorean theorem to get this side over here, which is the radius of the circle this point is on when the center is at 0, 0. And so 1 squared plus 5 squared square rooted is square root of 26. And so this should be cotangent here. No, that would, why did they go with cosine? Oh, I see what they did. Yeah, okay. So the cosine of this angle no, this angle well, the cosine of this angle and the cotangent of this angle, when you take the cotangent inverse, it's going to equal the cosine inverse of this. So the cotangent of 1/2. So this angle here gives us both 1/5 and 1 square root of 26. So when you take the inverse of that cosine and that tangent, you get the same angle. They could have done sine and said 5 over the square root of 26 and would have gotten the same angle, which is 0.37 radians. All right. So which cotangent has 1/2, negative 1/2? All right, again, they built the triangle because I know the x value is 1 and the y value is 2, but it has to be the angle has to be in this interval. Whoops. And so that's going to be this is going to be the long side here, the hypotenuse of the triangle, and the x value is going to be -1 and the y value is going to be +2 to be in this quadrant. But using the Pythagorean theorem, we still get the square root of 5 for this length. And they're going to do the same thing. They're going to say the cosine of that angle is 1 over the square root of 5, which is what they did. And it's going to be negative because this 1 is negative. And so all we need to do is the inverse cosine of -1 over the square root of 5 to get theta, which is approximately 2.03 radians. Now this one, to find the exact value of sine of tangent inverse of 4/3. Well, we look at creating that triangle. All right, so now the hypotenuse is 5. 3 squared plus 4 squared is 25, and the square root of 25 is 5. So we're going to replace the tangent with sine. So the tangent inverse of 4/3, this angle is the same angle that gives us the sine inverse of, well, sine is opposite over adjacent over hypotenuse. So that's going to be 4/5. So if I do the sine of 4/5, so no, so that means the tangent inverse of 4/3 is this, is the sine of 4/5. So I just replace the tangent inverse with this sine inverse. So now we have the sine of the sine inverse of 4/3. I mean 4/5. Well, the sine of the sine inverse is just the argument, which is 4/5, or 0.6 if you divide it out. And so, yeah, so they get the 5. All right. Oh, okay. So whatever angle theta is here, when I take the sine of it, I'm going to get 4/5. All right. They even made it simpler than what I did. Okay, we're at time, and I'm going to leave it here.
Yeah, my computer was running out of battery. It's perfect time. I just, as soon as you said that, I got a notification that said, computer running out of battery, charge, please, or please charge.
Okay. Well, I'm going to stop the share, and maybe things will change up a little bit. No. No, y'all are still in the dark.
What do you mean?
Your screens are black.
Oh, yeah.
I don't know what's been going on with Zoom. I may need to, Zoom has been doing updates, and I may not have updated the Zoom on my computer yet. So that may change it, but I don't know. I don't know. Okay. So I'll see y'all next time.
Goodbye, sir. See you next time. Have a good,
Bye.
let's say,
Be
Tuesday.
safe.
Bye-bye.